Okay, so we've used the rational root theorem and we've used Descartes' rule of signs, and now what we want to do is actually have a chance to put those together and solve a polynomial. So we're going to do this using that same polynomial that we used in both of those two examples in the videos. P of x equals 6 times x to the 4 minus 13 times x cubed plus 13 times x squared minus 39 times x minus 15. And we want to remember a couple of things that we learned in those last two videos. One was that the possible rational roots were plus or minus 1, plus or minus 3, plus or minus 5, plus or minus 15, plus or minus 1/2, plus or minus 3/2, plus or minus 5/2, plus or minus 1/3, plus or minus 5/3, plus or minus 1/6, and plus or minus 5/6. Wow, that's a lot of possible rational roots. Remember, we found those when we were doing the video on the rational root theorem. And we talked about the fact that there were so many of them, and that's why we wanted to use Descartes' rule of signs, because it helps narrow down how many roots we need to be really looking for. And what we learned was that there is 1 or 3 positive real roots. And we know that because we looked at the sign changes between each consecutive term. And we found that there were 3 sign changes, so there's either 3 positive real roots or it's less than that by an even number. So it's either 3 or 1. That means one of these rational roots has to be, one of the positive rational roots at least, has to be a factor or a 0. Also, we found that the number of negative real roots is 1. So in other words, at least one of these negative numbers has to be a root of our polynomial. That gives us some place to start with. So we know that if we find one negative, we don't have to check any more negatives. Well, let's get started. Let's find the positive, or all of the rational roots, or all of the roots of this polynomial. So what we're going to start with then is synthetic division. And we still don't know exactly where that we're going to start, but we have a very good hint here that there's one negative real root. So one of these possible rational roots, one of the negative ones, is going to be one of our roots. Why don't we start with -1? It's the easiest number that we can divide by, and we can go ahead and use synthetic division with it. So where do we start? Well, we'll start synthetic division, -1. So we put -1 on the outside of our synthetic division, and we put all the coefficients on the inside. So we have 6, -13, +13, -39, and -15. Now I'm going to go through this kind of quickly. Of course, you're going to use the pause button as you work, and if you don't remember how to use synthetic division, you want to go back to the video on synthetic division. So remember, we're going to drop the first coefficient, our leading coefficient, and we're going to multiply that times our divisor, so 6 times -1. And that gives us -6. And then we're going to add to that the -13. Okay, so we've talked a lot about solving polynomials, and we talked about the rational root theorem, and we talked about Descartes' rule of signs. And when we talked about both of those, we used the same polynomial. The polynomial was P of x, which is equal to 6x to the 4 minus 13x cubed plus 13x squared minus 39x minus 15. And when we used the rational root theorem, we found that there were a lot of possible rational roots, namely plus or minus 1, plus or minus 3, plus or minus 5, plus or minus 15, plus or minus 1/2, plus or minus 3/2, plus or minus 5/2, plus or minus 1/3, plus or minus 5/3, plus or minus 1/6, plus or minus 5/6. Okay, a lot of possible rational roots. And we talked about how the Descartes rule of signs then helped us narrow those down a little bit, because we found out that the number of possible positive real roots was either 3 or 1, because there are 3 sign changes in our regular polynomial. And then we found that the number of negative real roots was 1 because if we changed all of the x's to negative x and simplified it, we found there was one sign change. Well, what does that mean? That means that it helps us narrow down all those possible rational roots to positive and negative ones. But that's still a lot to have to check. So there are a couple other things that we can do, and we are going to find all of the real roots, actually all of the roots of this polynomial. So how are we going to do that? Well, the first thing I'm going to tell you to do is to go ahead and graph the polynomial. Now, you're going to graph it on your calculator, so you want to go ahead and pause it here. I've graphed it already on a calculator, and so I've got the graph here. And this helps us because looking at this graph, we see that we have one negative real root, and we have one positive real root. Now, a couple of things that tells us. That tells us that two of our roots have to be imaginary roots. However, we also know that of these two roots that we can see, they're either rational or irrational. We have all the possible rational roots listed. So if we're looking at this graph, a couple of things that we noticed right away. Right here, we know that we're counting by ones, that's our scale, and we know that this negative root right here has to be between -1 and 0. And the other thing we know is that this root right here, the positive root, has to be between 2 and 3. Now, if we look at all of our possible rational roots, that means we've got to go up there and look at our fractions. 1/2 plus or minus 1/2. Well, this doesn't look like it's -1/2. And here's positive 1/2. That's not it. Plus or minus 3/2. Well, 3/2 is more than 1, but it's less than 2. So that's not it here, and definitely not the negative. And plus or minus 5/2. So wait a minute, plus or minus 5/2, that would be 2.5, the positive part. Well, could this be 2.5? That's a great place to start. So we're going to check with that. We're going to use synthetic division, and let's try it. So we said that positive 5/2 is the one we're going to check. So we're going to use synthetic division with positive 5/2. Now remember synthetic division, it's an upside down long division sign. We're going to put that factor on the outside, and on the inside we're going to use the coefficients of our polynomial. So 6, -13, 13, -39, and -15. Let's go ahead and make that 39 look quite like 39, -39 here. Okay. Remember that when we do synthetic division, we drop the leading coefficient, and then we multiply by the divisor. If we take 6 and multiply it by 5/2, we get 15. The way we do that is we take the 6 and we can divide it by 2. That gives us 3, and 3 times 5 is 15. Now we add the 15 to our -13, and we get 2, and we multiply again. So 2 times 5/2 is 5. And 13 plus 5 is 18. And 18 times 5/2, well, 8 divided by 2 is 9, and 9 times 5 is 45. And 45 plus -39 is 6. And now we already know 6 times 5/2, that's 15. And 15 plus a -15 is 0. That's a remainder. That tells us then that 5/2 is definitely one of the factors of our polynomial. So if 5/2 is a factor, that 5/2 is one of our zeros. So if 5/2 is a 0, that means the factor would be x minus 5/2. Well, now we found one of the factors, and we now know another factor, and that would be 6x cubed plus 2x squared plus 18x plus 6. Remember, the zeros are remainder. And if you don't remember how to use synthetic division to find these factors, you need to go back and relook at that video. Let's keep moving on. If I looked at this, I have now two factors. I have one factor that's a cubic, and it has 4 terms, and I have one factor that's linear. My linear factor I don't really have to do anything else with, but that cubic factor I need to factor again. Now I could either try synthetic division again, but I'm not exactly sure that's going to work because this factor right here might be rational, but it might be irrational. So instead of doing that, I'm noticing that I could factor by grouping. What do I mean? Well, 6x cubed and 2x squared have something in common. They have a 2 and they have an x squared in common. When I factor that out, 6x cubed divided by 2x squared is 3x. And 2x squared divided by 2x squared is 1. Let's find out something. Is that going to help us if we now factor the 18x and the 6? Well, let's try it. If I factor 18x and 6, well, they have something in common. They have 6 in common. So I bring out the plus 6, and then I'm going to divide. 18x divided by 6 gives me 3x, and 6 divided by 6 gives me 1. Well, that, whoops, not 11, but 1. Well, what does that mean? That means that I can take the 2x squared and the 6 out. So I have that factor that I need to make sure I continue to bring down with me. And now I have 2x squared plus 6, and I have 3x plus 1. So now I have another factor in here. Well, what can I do with that? I could set each factor equal to 0, and that will help me to find all of the information that I need. So remember x minus 5 halves, when I set that equal to 0, I get 5 halves. If I take 3x plus 1 and set that equal to 0, we get 3x equals negative 1. So x equals negative 1/3. Well, that's another one of my solutions, or zeros. But what do I do about 2x squared plus 6? If you said set it equal to 0, you're right. So let's try it. 2x squared plus 6 equals 0. That means that 2x squared equals negative 6. So x squared equals negative 3. Well, how do I solve that? Remember, I have to take the square root of both sides. So x equals plus or minus the square root of negative 3. Ah, that's an imaginary number. X equals plus or minus I times the square root of 3. Remember that the square root of negative 1 is equal to I. So now I have my other two factors, plus or minus I times the square root of 3. I had a polynomial with a degree of 4. That means I have to have 4 zeros, or 4 roots. And I do. One is 5 halves, one is negative 1/3, one is negative I square root of 3, and the other is positive I square root of 3. Remember that the imaginary solutions don't show up on my graph. So graphing this allowed me to find one of my solutions. That allowed me to use synthetic division to find the rest of them. Take the time to pause, rewind, go back, and we'll do a bunch of these in class. But there was one more thing that we want to look at. Using these 4 zeros, how do I actually get all 4 factors? Because I only see 3 factors. Well, what we do is take each one of our zeros and rewrite it as a factor. So you might ask, what do you mean? Well, we already knew we had that x minus 5 halves. Since we have negative 1/3 as a factor, that means we have x plus 1/3 for a factor. We have that I square root of 3, the positive one, so that means we have x minus I square root of 3 for a factor. And finally, we had the negative I square root of 3. So x plus I square root of 3 is also a factor. So these are our 4 factors.